In Chapter 12, you're going to learn about several different types of lines and line segments that have to do with circles. Out of these lines, the most important kind is called the tangent line. When it comes to circles, a tangent refers to a line that intersects the circle at exactly one point. In this picture here, you could see how this tangent line just brushes by the edge of the circle. In fact, there's literally only a single point where the line is touching the circle. That single point where the line touches the circle is called the point of tangency. Next, open the postulate paper for Chapter 12 in Notability. Find Theorem 12.1. Theorem 12.1 tells us that if a line is tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. So here's the deal. If I know that this line here is tangent to the circle, then I know if I draw a radius to the point of tangency, it's automatically going to be perpendicular to the tangent line. In other words, it will make a right angle. So in a different color, make sure you highlight the right angle symbol to show that they are perpendicular. This theorem has several different uses when it comes to solving for triangles that overlap part of a circle. So here we have a triangle where one side of the triangle is the radius of the circle and another side of the triangle is tangent to the circle, just brushes by the edge but never goes inside the circle itself. Because this corner is where a radius hits a tangent line, we know that corner has to make 90 degrees. Draw in a right angle box there. And knowing that tells us that we can use Pythagorean's theorem, which only works on right triangles, to solve for the missing side x. Pause here and see if you can figure out the rest of question 1 on your own. So first, you're using Pythagorean's theorem. The c would be the hypotenuse, 17. You get x squared by itself and you square root, you should get x equals 8. Question 2 is similar, but I want to point out one thing before you try it on your own. I want you to notice that this time the hypotenuse side is a combination of an 8 section and an x section. In other words, you could call it 8 plus x or x plus 8. It's still a right triangle because it's where a radius hits a tangent line. You could still use Pythagorean's theorem, it's just that your c value will be quite a bit more complicated. So here's your tip. When you're plugging in a, b, and c, notice how c is, you could write either 8 plus x. Personally, I like to write the variable in front, x plus 8. And now pause the video and see if you could solve for x on your own. One thing I do want to point out that a lot of people forget is that when you have a quantity in parentheses squared, that really means you have two of the same quantity. So this parentheses x plus 8 squared really means you have x plus 8 times x plus 8. Oh, it's a FOIL problem! So when you distribute the x in the first parenthesis and the 8 in the first parenthesis, what you really get for the right side of your equation is x squared plus 16x plus 64. Now, when you try to get like terms together, you can minus x squared from both sides. Oh, they actually cancel each other out. Minus 64 from both sides. And then divide both sides of the remaining equation by 16 to isolate x. You get x equals 12. All right, I want you to pause here and try question 3 on your own. Go ahead and check your answer on question 3. You should get x equals 7. Now go back to your postulate paper. Find theorem 12.2. This is actually the converse of the last theorem. It's the same idea, but flipped backwards. Theorem 12.2 says that if a line is perpendicular to a radius at its endpoint on the circle, so you already know that these are perpendicular, you already know the right angle bit, then that tells you that the line must have been a tangent line. So in a different color, label this line a tangent line. This theorem will help you on problem number 4, where it asks, is segment MN here tangent to circle P at point N? Yes or no? Explain. Just a quick note, it's not clearly labeled here, but this whole thing is 13. It's not just this outside section, this whole thing is 13. So what you can do to test to see if MN is a tangent line is you could test to see if Pythagorean theorem works. Because if Pythagorean theorem works for this triangle, that tells us it's a right triangle, and if there's a right angle here, it makes MN into a tangent line. So your work to show it's a tangent line might look like this. You might say something like, yes, MN is tangent because Pythagorean theorem confirms it, and show how plugging in 5, 12, and 13 creates a true equation. Next, go back to your Pasha paper for theorem 12.3. This one's one of my favorites in chapter 12. If two tangent segments to a circle share a common endpoint outside the circle, like this endpoint P here, then the two segments are congruent. This theorem always kind of reminds me of those salad tongs that you use when you're eating fancy. It basically looks like salad tongs, and it's the same idea. If you have a point here where your two line segments start, to pick something up with the salad tongs, like this circle, the salad tong pieces have to be equal lengths. You could use that theorem to solve problems like this. Pause here and solve for x. And your work should get you x equals 3. Theorem 12.3 tells you that these two tangent segments that start at the same endpoint have to be equal to each other. Use that to create your equation and solve. That same theorem helps you solve problems like number 6. Circle S is inscribed in triangle LMN. Remember, the word inscribed is one you learned in chapter 5, and it really just means to draw the largest circle that can fit inside of a figure. So that's an inscribed circle in that triangle. What is the perimeter of the triangle? Well, you could break down this triangle into pieces. Notice how we're missing parts of the perimeter. We don't know this segment of the perimeter or any of this side of your triangle. So at first, it looks like we might be stuck. However, because you could break down the sides into pieces, like this piece and this piece, that are tangent segments that start at the same endpoint, you could say those pieces are equivalent. So you could get that this missing piece is 8. That can also be a method that can help you solve for the other missing pieces of this side. Pause here and solve the rest of number 6 on your own. So using theorem 12.3, you could figure out, well, if this tangent segment is 5, so is this piece. If this is 14, so is this piece that also starts at the same endpoint. Now you have all the pieces of your perimeter, and you can add it up to get your answer. Problem 7 is taking your first theorem, the idea that you have tangent segments, and applying it in a new way. So here it tells us that segment AD and segment AG are tangent to the circle. What is the value of angle X? Because you know both of these segments are tangent to the circle, you know they both make 90 degrees with a radius drawn where they hit the circle. Now you can combine that fact with what you know about four-sided shapes, quadrilaterals. Remember in chapter 6, you learned that rule that you could figure out the sum of the interior angles of a shape by plugging in a number of sides for n. So you could figure out for any quadrilateral, like this one, the sum of the 4 angles inside the figure should equal 360. Then you could say, well, if I add up those 4 corners, 90 plus 152 plus x, if I know that equals 360, I can solve for x and say x equals 28 degrees. Last problem. So they're telling us here that segment HG and HI are tangent to the circle, and they're asking for the value of segment D here. So the fact that HG and HI are tangent to the circle tells us a couple things. It tells us that they make a right angle where they hit the circle, and they also tell us that these segments are equal due to theorem 12.3. If this is 8, then this is also 8. And we also know that a radius in a circle is the same length no matter in what direction you draw it. So if this radius is 5, so is this radius. Now you could zoom on either of the triangle pieces, either the top triangle or the bottom triangle, and use Pythagorean theorem to solve. Pause here and solve number 8. Go ahead and check your answer on number 8. You should get around 9.4 centimeters for segment D. Great job, everybody. Don't forget to turn in a picture of your notes on Schoology when you're done.